All right, let's jump right in. If you're running workloads on GKE, you know you have three really powerful autoscalers available. But here's the thing. Using them by themselves is like having incredible musicians play without a conductor. So in this explainer, we're going to show you how to harmonize this trio so they perform together like a world-class orchestra, perfectly in tune with your app's needs.
So let's start with the big question, right? When that totally unpredictable wave of user traffic hits, is your cluster actually ready for it? The real goal is to scale gracefully without, blowing your budget or risking a catastrophic outage. The secret isn't just using the autoscalers, it's understanding the three fundamental ways you can scale.
First things first, let's get our vocabulary straight, because you've got three totally distinct ways to scale. You can scale out, that means adding more pods. You can scale up by making your individual pods bigger and more powerful, and you can scale the cluster itself by adding more nodes or machines for everything to run on. These are the three levers we're going to learn to pull in perfect harmony.
Okay, so our story begins at the application layer. I want you to think of your application pods as the musicians in our orchestra. They're the ones actually doing the work, and they have to respond to the changing tempo of user demand. And this is exactly where our first two instruments come into play, the HPA and the VPA. First up, we have the Horizontal Pod Autoscaler, or HPA. This is your rapid responder. In our orchestra, the HPA is like the nimble first-chair violin. It's not worried about the entire symphony, it's only focused on the immediate tempo. When the music speeds up, it instantly brings in more violins to match that pace. Now take a look at this. This is a classic scenario. A sudden traffic spike hits your web service. Your target for CPU is, say, 60%, but right now your pods are just screaming at 90%. This is the exact signal, that high note that our HPA is listening for. And here's exactly what it does next. The moment that CPU target gets breached, HPA does the math. It calculates exactly how many new pods it needs to absorb that load. Then, boom, it deploys them. No hesitation. It's a clean, fast, automated reaction designed to handle that burst right now.
But, that rapid response is only half the story. Now let's meet the vertical pod autoscaler, or VPA. If the HPA is that reactive musician, the VPA is the wise, thoughtful conductor. The conductor isn't playing an instrument. They're observing the entire orchestra over many, many rehearsals to make sure every section has exactly what it needs for a perfect performance.
And that really is its core job. See, VPA isn't distracted by those momentary spikes. It's a patient observer. It watches your pods over days, even weeks, to learn what they truly need in terms of resources. This is all about moving from just guessing to making data-driven decisions for long-term efficiency. And check this out. This slide shows you the impact perfectly. You might start with a generic guess, right? Maybe half a CPU, a gig of memory. But after watching for a while, VPA comes back with the tuned reality. It actually only needs a quarter of a CPU and 750 megs. This right sizing isn't just about saving money, which is great. It's also about stability, making sure every pod has exactly what it needs. No more, no less. So our application pods, our musicians, are now scaling beautifully. But even the best musicians in the world need a stage to perform on. And that brings us to Act 2, the infrastructure layer that holds it all up. This leads us to a really critical problem. So imagine this. The HPA, in its rapid response, just added 10 new pods to handle a big traffic spike. But what happens if your existing virtual machines are already full? Well, those brand new pods are just going to be stuck in a pending state with absolutely nowhere to run.
And that is exactly where our stage crew, the cluster autoscaler, comes in. Its one and only job is to make sure there's always enough stage space. When the orchestra gets bigger, it builds more stage. When it shrinks, it clears it away. Simple as that.
And the process, as you can see, is actually elegantly simple. The CA spots those pending pods, sees there's no room, and immediately provisions a new node. Crisis averted. But here's the other half of its job, which is just as important. When traffic dies down and a node is just sitting there, underutilized, the CA safely drains it and shuts it down. So it both adds capacity when you need it and eliminates waste when you don't.
Okay, so we've met our rapid responder HPA, our wise optimizer VPA, and our stage crew CA. Each one is powerful on its own, but the real art, the real magic, is getting them to perform together as a seamless, coordinated symphony.
Now listen up, because this is probably the most important rule of this whole explainer. You absolutely cannot have HPA and VPA fighting over the same metric, especially CPU. Just imagine, HPA sees high CPU and says, we need more pods. At the exact same time, VPA sees high CPU and says, no, we need to give the existing pods more CPU. This creates a conflicting loop that can completely thrash your deployment and destabilize your whole application.
So the solution is to give everyone a clear division of labor. Let HPA, our rapid responder, handle the bursty, short-term metric CPU. Then let VPA, our wise conductor, handle the long-term right-sizing of memory, which is critical because a pod either has enough memory or it just crashes. And underneath it all, the cluster autoscaler, our stage crew, simply provides the infrastructure whenever it's needed. Each has a distinct, non-conflicting role. It's beautiful.
All right, we've covered the theory. Let's get practical. Here is a blueprint, a really solid production-ready starting point that you can take and apply to your own GKE clusters today.
So here's your blueprint. Step 1, cluster autoscaler is just non-negotiable. Always have it on. For your stateless web services, set up an HPA targeting about 60 to 70% CPU to handle those traffic bursts. Now for VPA, and this is key, start it in recommendation mode on everything. Think of this as your safe discovery phase. It won't change a thing, but it's going to give you incredible data on what your apps truly need. Once you have that data, you can tune your requests or confidently flip on auto mode for memory on your critical apps.
And that really is the key takeaway here. The goal isn't just to scale. Anyone can do that. It's about scaling intelligently. It's about transforming these individual tools from what could be a chaotic jam session into a truly coordinated, harmonious orchestra.
You know, by following this blueprint, you'll build a cluster that reacts beautifully to whatever demand is thrown at it. But that leads to a final thought. The next frontier isn't just reacting to demand, it's predicting it. Thanks for tuning in.